Okay, let's discuss information theory. Information theory is a theoretical study of efficient use of bandwidth to propagate information in a communication system. It is being used to, number one, determine information capacity in a specific channel. No, ibig sabihin, kaya niyang malaman gaano ba kalaki yung kaya niya na information, no? Of course, with a specific bandwidth. Second, determine the rate of propagation of information. Ibig sabihin, yung bilis ng pag-propagate ng data, no? Or information. And last but not the least, to know the best type of transmission technique in a specific communication application. Kaya niya rin malaman kung ano ba yung efficient na gamitin, no, na transmission technique in a specific application. So, pag-aaralan natin yung mga line encoding techniques. Okay? So, information capacity, it represents how much information can be transmitted through a channel given a period of time. And usually, minimeasure to in bits per second. Most basic digital symbol used to represent information is the binary digit, or in short, bit. Okay? So, quick history lang, no? In 1928, information theorist Ralph B. Hartley of Bell Labs, no? Kung familiar kayo sa Bell Laboratory, dito na invent yung transistor natin, no? So yung three scientists natin, no, diyan nila inimbento sa Bell Laboratory. Okay? So sa Bell Laboratory in 1928, pinublish nila yung article, no, called Transmission of Information, which he proved that the total amount of information that can be transmitted is directly proportional to the bandwidth of the channel and the time duration of the transmission. Okay, so ang tawag doon sa law na yon is the Hartley's law. Okay, which is the equation, no, na information capacity is directly proportional to the bandwidth multiplied by the time duration. So yung I is measured in bits per second, and B is measured in hertz, and T is measured in seconds. Okay? So let's have a simple problem regarding information capacity. Punta tayo dun sa kabilang software and doon natin isolve. Okay. Sabi dito, a data with an information capacity of 32 kilobits per second is transmitted to a given channel with a bandwidth Bhz in a period of 2 seconds. Assuming all parameters are the same, what is the information capacity on a second data to be transmitted on the same channel given a period of 3 seconds? So, binigay yung information capacity ni information 1. So, gamit ako dito ng pencil. Okay? So, I1 is 32 kilobits per second, and nagbigay siya ng bandwidth. B1 is Bhz, and mayroong time duration na 2 second. Okay, so sabi, assuming all parameters are the same, and same channel din yung medium nung ating second information, ang tinatanong is, ano yung information capacity ng pangalawa. Okay, assuming all parameters is the same, ibig sabihin same channel, parehas ng bandwidth, Bhz. Pero this time, 3 seconds naman. Okay, so formula natin, for Hartley's law, or information capacity is equals or directly proportional to bandwidth multiplied by the time duration. So, alam naman natin na yung constant of proportionality, pagka pinalitan natin yan, meron niyang parameter na K, B, T. Okay? So, pwede natin gawin na since parehas lang naman yung bandwidth ng dalawang information. So, solve natin si KB in terms of the information capacity and the time duration. Okay? So, since KB1 equals KB2, So, I1 over T1 equals I2 over T2. So, si I1 given ay 32 kilobits per second divided by 2 second. I2 divided by 3. So, 3 over 2 times 32. So, ang sagot natin is 48 kilobits per second. So, ito yung information capacity nung pangalawang information natin. Okay? Okay, so now let's discuss Nyquist channel capacity. So, dito naman, nagpo-focus tayo sa noiseless channel. Okay? So, sabi ni Harry Nyquist, if a binary signal goes through a noiseless channel with a bandwidth of Bhz. Okay? Sabi niya, the maximum information capacity of that channel with a given bandwidth Bhz is just twice of it. Okay, so ibig sabihin, if meron pumasok na binary signal, okay, sa isang noise-free channel with a bandwidth Bhz, yung maximum information capacity nitong channel na to is just twice. So, ibig sabihin, kung meron siyang bandwidth na B, ang maximum information capacity na kaya niya lang i-accommodate is 2B bits per second. Okay, so ito yung max bit rate niya. Okay? So another example, no, it means that if a given channel has a 5 kHz bandwidth, the maximum information that it can be transmit is 10 kilobits per second. So ganun lang siya kasimple, no? Twice lang nung bandwidth ng specific channel. Of course, kung ang signal na ipapasok natin ay binary, ibang usapan pagka hindi na binary yung signal. Or pag sinabi kasi binary is either 0 or 1 yung amplitude level niya, no? So mamaya pag-uusapan natin 'yan, no? Pag hindi na binary yung papasok na signal. Okay? So ito na. No? So what if I increase the number of bits per signal level, no? What if 4 possible outputs per signal level or 8 possible outputs or 16 possible outputs. Okay, ang gagamitin na nating formula or general formula is the Nyquist channel capacity or meron ng M. No? Ang tawag dito actually is the MRE signal level. Yung information capacity is twice ng bandwidth logarithm base 2 ng M, no? Where yung M is equals to 2 raised to N. Yung M is the number of possible output combinations per signal level and N is the number of bits na ginamit doon sa signal level na yun. Okay, so ibibigay naman sa problem yun. No? So let's have an example. If a binary digital signal is to be transmitted at 10 kilobits per second, what is the absolute minimum bandwidth of that channel required to pass the fastest information change undistorted? So, madali lang to, no? Hindi na natin kailangan isolve. So, i-divide lang natin ng 2 yung maximum bitrate na yun. And yun na yung magiging bandwidth ng channel na yun. So, in this case, ang sagot natin dito is 5 kHz. Okay? So, ganun lang kasimple. So, yung M kanina na is equals to 2 raised to N is called the MRE signaling. No? This is the type of digital signaling technique used for digital transmission which instead of using 1 bit per signal level, okay, it uses 2 or more bits per signal level. Okay? O which is yun yung 2 raised to N natin. Okay, so let's have an example. Given a binary data with an information capacity of 64 kilobits per second and another data of 128 kilobits per second, if the given bandwidth is 16 kilohertz, how many bits was added from 64 kilobits to 128 kilobits per second? So, gamitin natin yung general formula which is I equals 2B log 2M. Okay? So, binigay dito yung information capacity nung una, 64 kilobits per second. And I think I assume na pares lang sila ng bandwidth, no? So, 64 kilobits per second. So, 2, 16 kilohertz log 2 M. Okay, so kunin natin yung M. So So, 64 kilobits divided by 2 divided by 16 kilohertz. And log 2m is actually equals sa log m divided by log 2, no? So, palitan nyo siya, no? This is called the change base formula ng logarithm. Okay? So, times log 2 and inverse log. So, yung m natin dito is 4. Okay? Next, kunin natin yung sa 128 kilobits per second naman. So, 2, same pa rin, 16 kilohertz, log 2m. Okay. So, solve natin si m, 128, 216 times log 2, inverse log, so 16. So, si m ay, ito yung number of levels, no? Hindi pa yan yung number of bits. Ang tinatanong is number of bits. So, ang gagawin natin, i-equate natin to sa 2 raised to n. Equate sa 2 raised to n. So, ito, obviously, yung n is 2. And ito ay, obviously, is n equals 4. So, ano yung in-increase niya? How many bits is added? So, delta n is equals to 2. Kasi from 2 bits, naging 4 bits. So, yung dinagdag or yung in-increase from 64 kilobits information capacity papunta sa 128 kilobits per second is 2 bits. So, ang sagot natin dito is 2 bits. Okay, next. The Shannon channel capacity, no? So, this time naman, yung channel natin is i-assume natin na noisy. Okay, so may presence na ng noise. Okay? In 1948, Claude E. Shannon with Hartley, who worked in Bell Laboratories, found a relationship between the information capacity of a communication channel to bandwidth and signal-to-noise ratio experimented in a noisy channel. So, sabi nila, the information capacity is equals to the bandwidth of the channel, logarithm, base 2, ng 1 plus S over N. Yung S over N is the signal-to-noise ratio. So, the higher the signal-to-noise ratio, the better the performance and the higher the information capacity. So, ang tawag dito, since nag-work together sila ni Hartley, is the Shannon-Hartley theorem. Okay? Okay, so let's have an example. Assuming for a standard telephone circuit with a signal-to-noise ratio of 1,000 and a bandwidth of 2.7 kHz, what will be the information capacity that can be transmitted? Okay, so by using the formula, I is equals to B log 2 1 plus S over N. So, direct substitution lang, no? 2.7 kHz log base 2 1 plus 1,000 so log 2 1,001 2.7 kHz. So ang sagot ay 26,911 bits per second. Okay, wag kayong malilito, no? Hindi porket hertz etong bandwidth, hertz na rin ito. Okay, tandaan natin information capacity yung pinag-uusapan natin. So bits per second yung sagot. So pwede nyo i-round off, pwedeng maging 27 kilobits per second. Okay? So tingnan natin kung tama tayo. So tama naman, no? 26.9 or 27, no, is the allowable capacity limit in a given channel of a bandwidth of 2.7 kHz and SNR, no, or pag sinabing SNR is signal to noise ratio of 30 decibel. 30 decibel kasi is 1,000. So ito yung capacity limit or sometimes tinatawag siya na Shannon limit. Okay?